Valuation of Alex is 1.1. The valuation of Bert is 1.2. Valuation of Alex and valuation of Bert. The question says, show that there is an equilibrium. There is an equilibrium. There could be many equilibrium. I am just required to show that one of them is an equilibrium in which both bidders bid their own valuations. In other words, translate this sentence into mathematics, into a mathematical expression. I am asking you, show me that BA is equal to BA is equal to 1.1. This is Alex's bid, right? Alex's bid, yes. And BB is equal to BB is equal to 1.2. This is Bert's bid. These bids constitute a Nash equilibrium. That's what I am asking you to show. Okay, show that this is an equilibrium. I'm asking you to show me that when Alex bids 1.1 and Bert bids 1.2, that's a Nash equilibrium. You have to prove that. And the idea behind it is pretty simple. Look, in order for these two bids to be a Nash equilibrium, what must I show? I must show that given Alex is doing this, Bert can do no better than by doing this. Any other bid he makes, it will give him either the same payoff as bidding this or a lower payoff. That's what I have to show. And given that Bert is doing this, Alex should have no incentive to move away from this bid. In other words, bidding any other value would give Alex either the same payoff or a lower payoff. Once I have done that, once I have demonstrated that, I have shown you that these pair of bidding strategies is a Nash equilibrium. Okay? To understand what it means to show that a pair of bidding strategies is a Nash equilibrium, we must show that given what one player is bidding, the other player has no incentive to make another bid, and given what the other player is doing, the first player has no incentive to make another bid, to switch to another bid. Okay? Here is how we do it. Look, once you understand what it is for these pair of bidding strategies to be a Nash equilibrium, the problem is very simple. Let me show you. Let me hold this bid constant and show you that Bert has no incentive of shifting away. Okay? Alright, here we go. So Alex is bidding his valuation, which is 1.1. Remember, this is the second price deal bid option. The question tells you. Okay. I'm going to hold this constant. And I'm going to find out what is the payoff to Bert when Alex bids 1.1 and Bert bids 1.2. Let me first figure out what is the payoff with this pair of strategies to Bert. What is the payoff? Alex is bidding 1.1, Bert is bidding 1.2. Who will win the auction? Alex is bidding 1.1, Bert is bidding 1.2. Who will win the auction? Bert will win the auction. He has a higher bid. Bert will win the auction. But this is a second price auction. Will he pay how much he bids? No, he will pay Alex, the second highest bid, which is 1.1. Therefore, his payoff from this pair of bidding strategies, Bert's payoff from these pair of bidding strategies is valuation minus price. What is his valuation? It's 1.2 minus what is the price he is paying? The second highest bid, 1.1, 0.1. Okay, this is Bert's payoff from this pair of bidding strategies. Let's change Bert's bidding strategy. Holding Alex's bidding strategy constant, let me change Bert's bidding strategy and consider what happens to his payoff. Here we go. Suppose Alex continues to bid 1.1. Notice I am holding this constant. Bert bids greater than 1.2. Greater than 1.2. In which case, who will win the auction? Clearly, Bert will win the auction still. Still, Bert will win the auction. He has a higher bid. If he will win the auction, how much is his payoff? The price he will pay is the second highest bid. His valuation is 1.2. Therefore, his payoff from this pair of bidding strategies is 1.2 minus 1.1, 0.1. Question. Look at this payoff, look at this payoff. Given that Alex is doing this, does Bert have any incentive of switching from this bid to this bid? Does he? No. Same payoff. No switching. No incentive. Okay? Now, consider another bid. There are only three possibilities, right? This is 1.1, this is 1.2. I have looked what will happen when Bert bids 1.2. I should look what will happen when Bert bids anywhere here. I should look what happens when Bert bids anywhere here. Once I have considered the three possibilities, I am alright. Okay? So now, next, the payoff to Bert when Alex bids 1.1, notice I am holding Alex's payoff the same. Alex's bids the same. And Bert bids anywhere between 1.2 and 1.1, anywhere between these. What will happen? Who will win the auction? Alex is bidding 1.1. Bert is bidding more than 1.1 but less than 1.2. Who will win the auction? Bert. Clearly Bert. What price will he pay? Second price auction, he will pay the next highest bid, which is 1.1. Therefore, his payoff will be 1.2, his valuation minus the price he pays, 1.1, which is 0.1. Ask yourself the question, given that Alex is doing the same thing here, here and here, does Bert have any incentive to switch from here to here? No. Answer is no. Payoffs are the same. Finally, consider this possibility. The payoff to Bert, Alex is still bidding 1.1. Now Bert decides to bid a number less than 1.1. Imagine that when two bidders try, we have no idea what will happen. Okay, so Alex bids 1.1, Bert bids less than 1.1. Who will win the auction? Alex will win the auction. What will be Bert's payoff? 0. Therefore, does Bert have any incentive of switching from here to this bidding strategy? No. Therefore, given what Alex is doing, does Bert have any incentive of switching from 1.2? No. Okay. Now that does not show it is an equilibrium set of strategies yet. You have to do exactly the same thing I did with Bert for Alex. That means you will have to now, so this is holding Alex's bidding strategy constant. Now what you have to do, you have to hold Bert's bidding constant at 1.2 and look at the payoff of Alex. Does Alex have any incentive to deviate from bidding 1.1 when Bert is bidding 1.2? So holding this constant, you look at all of the other possibilities. First look here. This is the original value, okay? So Bert bids 1.2, Alex bids 1.1, who will win the auction? Bert will win the auction, therefore Alex's payoff is 0. Alex's payoff is 0. Similarly, consider what happens when Alex bids less than 1.1, while Bert is still bidding 1.2. Okay? In a similar manner, once you have found this value, less than 1.1, Bert will still win the auction, Alex's payoff will be 0. Then you will ask yourself, does Alex have any incentive of switching from this strategy to this strategy? And the answer will be no. Okay? You do it for all other possible combinations of Alex's strategy. Okay, I leave it there. Alright? And you will find out that given what Bert and Alex are doing, the other player has no incentive. Given what Bert is doing, Alex has no incentive of switching to another bidding strategy. Given what Alex is doing, Bert has no incentive of switching to another bidding strategy. Therefore, we have shown that both players bidding their own valuation is an equilibrium set of strategies. Okay? It's a Nash equilibrium set of strategies. And the important concept here, to answer the question, you have to be very familiar with what the concept of a Nash equilibrium is. That's paramount. You also have to be familiar with the rules of the second price option. That's it. Okay? The rules of the second price option. Whatever you bid, you will win if you make the highest bid, but you will not pay that bid. You will have to pay the next highest bid. Alright, so that's it. Huh? I'm leaving you guys to make sure that the other parts also work out. Next part of the question. So I have decided that this is an equilibrium set of bidding strategies for Alex and Bert. I have proved this. Next part of the question, who gets the house? And notice conceptually, who gets the house is a part of the equilibrium outcome of this game. Equilibrium outcome of this game. Again I say equilibrium outcome of this game. The outcome that will result when players use their equilibrium strategy. That's an equilibrium outcome. Here I have located the equilibrium strategies. When both players play their equilibrium strategies, I am asking you what will happen to the game. Who will win the auction? Bird. Who will get the house therefore? Bird. Yeah, exactly. Exactly. Bird will get the house. What is the house sold for? 1.1. 1.1. That's the equilibrium outcome of an auction game. Who wins the auction? What price does the winner pay for the house? That's part of the equilibrium outcome. What are the equilibrium payoffs in this game? Bird's payoff is 1.2 minus 1.1, 0.1. Alex's payoff is 0 because he does not win. Okay? So equilibrium strategies first, then you ask yourself what happens when players use these equilibrium strategies. Who gets the house and how much does he pay for it? Then finally I can ask you what are the equilibrium payoffs in the game. Which player gets what? In equilibrium. Okay. Alright. Look at the next question.